Hello everyone. In the previous videos, we have learned about what an artificial neural network is, what are its type, and how does it function. I've also mentioned that there is an important component in the neural network which governs how the network works and how good it works. So, in this video, we will try to touch upon that aspect. So, we will be talking about what is an activation function, what work does it do in a neural network, what will happen if a neural network does not have it, and what are the various type of activation functions, which are quite basic types of functions which anyone can use to develop a good neural network model. So let's get into it. What is an activation function? Activation function generally refers to the state of the neuron in which it is. This state of the neuron which we define determines what kind of output we get. So this state of the neuron, it receives inputs and it is the function of input which is transferred to further neurons to be able to develop an output. So as I've mentioned, this function is transferred to all the neurons in the network, thereby converting our input signal into the output signal by following certain rules. So how does this happen? Initially, when you give an input, the weighted sum of the inputs is taken into the activation function and converted into a different pattern or a format, if you can say, and given to the hidden layer for conversion, and an output is received. This function, as I've mentioned earlier in the previous videos, adds the nonlinear element into the neural network, as the main aim of many of the neural networks is to develop a nonlinear pattern which are resembling to the natural patterns in the world. Let's take a neural network and try to understand how the activation function works. As you can see, this is the input layer. So when we give an input to the input layer, before it is transferred to the hidden layer, it is converted into weighted sums. As I have mentioned, these weighted sums are converted based upon weights assigned to each element of the input as well as bias. What is bias? Bias generally represents a component of error where some elements are given very high weights whereas other elements are given very low weights. We can say that the model is leaning towards one side instead of having a uniform pattern if we needed it. So that element is also added before the data reaches the hidden layer. So how does an activation function work in this, and where does it come into play? So when you have calculated this weighted function, the sum of the weighted functions is taken into the activation function, converting a value of y if we give it a name, and it takes itself into the hidden layers. And during analysis of this hidden layer and when moving into the other layer, a new function is created based upon the analysis it has done in the hidden layer, converted to the output we need, and it is given to the next, and so on until the thing which we want is reached, like the parameters which you have kept is reached, and an output is given. So in this way, the activation function converts the weighted sum of inputs through its given mechanism into an output based on while satisfying all the functions which we are given. So that is what an activation function is and how it works. So let's see what will happen when we don't have an activation function. What does a neural network do when it does not have an artificial function? Activation function. It becomes a simple linear function because, as I mentioned earlier, activation function adds the nonlinear element to the system. Hence, this system becomes a linear element like a linear regression model, and it is easy to solve as it is known by anyone that a linear model like y is equal to ax is quite easy to solve when compared to a model with a higher degree or of 2, 3, 4, and so on. The main issue is if we don't have an activation function, it cannot develop a complex pattern. Thereby, we cannot understand the natural patterns in the system easily compared with having an activation function. So, this is a drawback if you don't have an activation function in a neural network. So let's come to the point. What are the different types of activation functions? There are multiple activation functions with varying degree of complexity. In this video, we'll be dealing about the basic functions which you can understand easily and apply. The first one being binary step function, linear function, sigmoidal function, and hyperbolic tangent function. So what is a binary step function and how does it work? Binary step function is essentially a single layer function which develops a relationship between input and output and tries to convert it. As the name suggests, it's binary, its results would be either 0 or 1. How does this binary function work? It, the basic working of this binary function is it works based upon a threshold. Like it works based on a principle where if a certain rule is satisfied, then itself the neuron is activated. Until then, the neuron is deactivated. So, although this is found useful in previous years, the main issue being, as I mentioned earlier in the videos, the feed forward back propagation function is quite useful because it takes the errors back and gives a better result in the next run. But when we use this binary function, we lose the advantage of feed forward because, as I mentioned earlier, the values are either 0 and 1. So when we try to calculate a gradient of the function, this backpropagation becomes 0 because the gradient essentially calculates the derivative of the function, where there is a higher probability of getting 0 in a binary function. Hence, the error does not get uh, brought back into the system because the function states it is 0, because the gradient becomes 0, and this loop cannot run, hence this cannot be used for back propagation. So let's come to the point, what is a gradient? Gradient is calculated, like what is a gradient and how is it calculated? Gradients are the elements which are used for calculating the errors between the observed data and the input observed data and the predicted output which we get. They calculate the errors in them and what are the biases in them and try to bring back into the system in a back propagation system and try to correct the elements so that you get a better output. As I mentioned here, the gradient function is nearing to 0 or becomes 0, so this back propagation function cannot be used here. Hence, if anyone wants to use a backpropagation function using binary step, it is not advisable. Coming to linear function. Linear function generally implies a direct relationship between the input and output. As I mentioned earlier, it is y is equal to ax. So in this, a is an element which has a constant value. Hence, it has a constant value and it does not have 0, so it can be used for backpropagation. Although it is used for backpropagation, it also inherently has a drawback. Because the value of A is constant, even though you bring back the error, the reason is the gradient does not change because of the constant element of the A, and hence the backpropagation does not correct anything in the system and thereby provides the same result over and over again. So this function, if you want to use backpropagation and try to develop a network which corrects its errors automatically, this function also is not advisable. Coming to sigmoidal function. Sigmoidal function is the most widely used activation function uh, because of various advantages which it possesses compared to its previous functions which I have mentioned earlier. This function transforms the value from between the value of 0 to 1. As mentioned earlier, this function is a nonlinear function which tries to convert and predict nonlinear pattern in a system. This system can be used for uh, backpropagation networks as it's not nearing to 0 and also it does not have any constant value. This function takes a shape of S when plotted around with normal values. As you can see here, this is the range how a function works when it is put between the positive and negative axis, with gradation starting as back as -4 to +4 as shown here, but it starts even before that. This function is quite active from -3 and 2 plus 3 in terms of a continuous system if we see, because here the values of the gradients are significant and they are not near to 0, sorry, not equal to 0. But there is an issue with sigmoidal function. If the values are behind -3, that is -4, out of the bounds, this value becomes, the gradient value becomes non-significant, thereby this function does not provide any good results. Also, when we come near to 0, the network starts to stop learning and thereby producing redundant information instead of a new output. The reason being why this function does this concept of becoming dormant is because of non-symmetric nature near the 0 value. What happens near 0 is all the outputs which we get are of same sign. Let's assume you wanted to predict 2 and your output is 3, though, so the error should be -1. But when it comes to the sigmoidal function, when converting these values and you see that the gradient is uh, lower and it's near to 0 and the value never becomes minus, like the never becomes minus and plus at the same time. If you have two elements in the system with error -1 and +1, it is represented either as -1 or +1 thereby having an issue when coming to the values near to the 0, and hence because of this there is a misinformation near the value of 0, and hence this function cannot produce better results when the gradient is nearing to 0. But there is a possibility of preventing this issue. Scaling of this function is found to be good in preventing this issue. This issue is addressed by hyperbolic tangent where scaling is done. What do you mean by hyperbolic tangent? It is a function which is similar to sigmoidal function in both its functioning, only the range changes where its range is from -1 to +1, and near the origin where I mentioned for sigmoidal function it's not symmetric and it gives only one sign near the 0. Here it is symmetric and it provides both the signs both positive and negative, thereby helping the network to develop a better model and give a better result. Hence, this network is considered to be better than the sigmoidal function, and it is used when you need a better model than sigmoidal function. Generally, sigmoidal functions are mostly used for classifying functions and many more. So, these are the four functions which are basic in any neural network model and can be tried out for developing a basic model like sigmoidal and tan H models, giving a better complex networks compared to the predecessors of linear models. This is it for this video, and I hope you got a brief view of all the four models and how they function and where we can use possibly compared to the type of model we want to develop. In the next videos, we will see how we can use this approaches which we have discussed in developing a basic model using MATLAB. Thanks for watching. If you like the video, please subscribe and share it with anyone whom you think this information will be useful.